Welcome back to the attic. I finally figured out what happened to my solid state relay, that 60 amps DC, and I only had a current of about 5 amps possible through it, and it was kind of what I expected. Now I was kind of pissed off when I opened it up and saw this epoxy in here, and I thought I could get it apart, and I was able to. And I guess someone was having a greasy lunch or something, because I was able to get out the FET and read the part number. And it's an IRFP4332. And they call this a 60 amp relay. So International Rectifier says at 25 degrees C, and that's junction temperature, it's capable of 57 amps. And at 100 degrees C, it's capable of 40 amps. So, yeah, it's not really 60 amps. The other thing is that the gate, for any appreciable current, has to be above 6 volts. And what I was suspecting, I was trying a little experiment, feeding a Zener into the input terminals, because this is supposed to turn on at about 3 volts and turn off at 2 or something like that. But I was thinking that if this had a circuit in it that was like a normal gate driver, once the voltage dropped a little bit, it would turn off. It would have these snaps. There's no snap to this. It's a snap on. So right now I got the voltage set at 1.6 volts, and I've removed the FET, of course. One thing nice is that, evidently they don't have things too clean. The epoxy pulled right off these. You look at this thing and you're thinking you're getting a thick plate, and you're not really. It's just a thin plate. It's embossed up a little bit higher where the FET goes. And unfortunately, when you take the thing apart, you have to go in with a chisel and sort of nick it a little bit higher, so you could get this between this metal and the plastic. But it does snap apart, so these are repairable. And of course the bottom, they designed this with, they put some epoxy in it, but before that, because they didn't want to waste any epoxy, they sealed the thing up with silicone. So there wasn't that much epoxy that could leak through. They just had this little hole cut for the square, and that was just about this size here. And not much got to the bottom, so pretty easy to unsolder these and put another FET in and put it back together if you want. But right now I have the this voltmeter is measuring the gate voltage, and across these terminals is 1.6 volts, and I'll just crank it up. 1.7, 8, 9, 2 volts, 210, 220, 240, 250, 260, 270, 290, 310, 20, should turn on pretty soon. There we go. 3.4 volts it turns on. And you can see it's 9.46 volts on the gate. And, that's a good gate drive. So now we just crank this thing down. Okay, now we're at 3 volts. So it's at 8, 7... So it's 2.4 volts right now. Let's bump it up 2.5. 2.5 is 6.6. So you could still get some reasonable current through it. Okay, 2.5, it's dropping. 2.4, 2.3, 2.2, 2.1, 1.9, 1.8. 1.7, 1.6. So you can see it gets very linear, At 1.5 volts, it finally drops out. But if you're driving one of these with an analog circuit, you can get into big trouble. So, these are good on, dry contacts. And if you have something with a Schmidt trigger to snap the electronics on and off, that's good to drive it. But if it gets into a linear region, you're going to burn these things up fast. So that's it. I kind of thought that was really interesting that they don't have any circuit in there to shut it off once the voltage got below, 8 volts or something like that. But there you go, the little transformer. There's one little transistor in it. I haven't traced this out. I don't know if I will. It's a lot of epoxy there, but don't ever use these on analog circuits. That's the message for today.